Hey everyone, so I'm going to do a video on dividing radicals. So the first thing you want to divide with radicals is you want to try to divide the outside numbers, the coefficients. 5 does not divide by 4, so we're going to keep it as 5 over 4 in this case. So my first thing I'm going to write is 5 over 4. And then I'm going to try to divide my insides. This 5 and 20, they both go into 5. This would become a 1, and this would become a 4. So I'm going to replace this with a 1 and this with a 4. So really what I have is the square root of 1 over the square root of 4. Okay, so the square root of 1 is just 1, so 5 times 1. And then the square root of 4 is 2, so 4 times 2. So I'm going to have 5 over 8 as my answer, because my bottom is 4 times 2. And the next one, I'm going to do the same thing. 3 is on the outside by itself, so I'm just going to write 3. I'm going to try to reduce 50 and 2. That does reduce, and actually I don't even think I need this line, because if I look at this, 50 and 2 will divide perfectly to 25. And x cubed and x will divide perfectly to x squared, because I'm subtracting the exponents. And then y to the 5th and y will divide nicely to y to the 4th. So now I'm just going to reduce my radical. 25 is perfect, so that will come out as a 5 next to my 3. X squared is also perfect, that will come out as an x. And y to the 4th is also perfect, that will come out as y squared. Again, this is happening because you're dividing the power, which is 4 in this case, by the index, which is 2. 4 divided by 2 is 2. And now I'm just going to bring them together by multiplying 3 times 5, and that gets you 15 x y squared. Okay, so for this one, I'm going to try to reduce my radicals like the previous ones, but 2 does not divide by 3. 1/2 is just going to stay there because there's a 1 here. So what I have right now is an issue because I can't reduce my radicals. So when I have this type of situation, what I want to do is I want to try to release the radical from the denominator, because right now this is fully simplified. There's nothing I can do. So I need to rewrite my expression without the radical in the denominator, because in math we don't like square roots or any type of radical in the denominator. Right now I have the square root of 3. In order to get rid of that square root of 3, I'm going to multiply the top and bottom by the square root of 3. Okay. 2 times 3 is radical 6, the square root of 6. And then 2 times 2 and then square root of 3 times the square root of 3 gets you the square root of 9. And the square root of 6 is now over 2 times 3, because the square root of 9 is 3. And that ends up getting me the square root of 6 over 6. This is my final answer. I cannot reduce the 6's because one is inside a square root and one is not. So if you notice, multiplying by the square root of the bottom released that radical and made it the 6. But I had to do it to the top and bottom in order to keep my fraction balanced. With the next one, I have a binomial in my denominator. In this case, what I'm going to do is multiply by something different. So in our previous example, we had a monomial in our denominator. We only had one thing. It was 2 square root of 3. In this case, I have 2 minus the square root of 3, two separate terms, so I have a binomial. When you have a binomial, you will multiply the top and bottom by the conjugate. So the conjugate is the opposite sign of the denominator. So when I say multiply by a conjugate, I'm multiplying by something that has the opposite middle sign. Only the middle sign is changed. The denominator is the issue here, so we're going to multiply by the conjugate of the denominator. The numerator doesn't matter, it's the denominator, because that's where the square root is. So what I'm going to do is I'm going to distribute negative 3 into the top. If I distribute it here, I get negative 6, and then I get negative 3 square root of 3, because remember, this is positive. Alright, for the bottom, I'm going to have to use box method, and to plus the square root of 3. Okay. 2 times 2 is 4. Then I have negative 2 radical 3. And then I have positive 2 square root of 3. And I have the negative square root of 9. What you should notice happens here is that these cancel, which is a good thing because we don't want square roots in the bottom, so the fact that these square roots are canceling is a good sign. I'm left with 4 minus the square root of 9. That's really 4 minus 3, which becomes 1. So my denominator is 1, meaning my final answer is just negative 6 minus 3, the square root of 3. Done. Now, a few things, because conjugates allow you to release, get rid of all the radicals, you could just plug this denominator into your calculator with parentheses, of course, like you would have to put parentheses around here, and that would give you 1. Another way to do a shortcut with multiplying the denominator, since they cancel, you can avoid doing all this work with the box by only multiplying the first, would be 4, and the last, which would be negative square root of 9. And that, because they're opposite signs in the middle, allows you to do that shortcut. You only need to multiply the first and the last. But anyways, when you have a binomial in the denominator like this, and there's a square root, you need to multiply the top and bottom by the conjugate.